Good morning, students. So we're gonna talk right now about the law of cosines, and again, like the law of sines, it's just to solve triangles that are of any kind. Okay. So again, just a triangle. It's actually three different dots where we have connected those dots with segments, linear segments, right? So that's what we have. Just dot A, point A, B, and C, and we have connected them. Now, just like the law of sines, we're gonna call the opposite angle of B. We're gonna call it B. The opposite angle of A, we're gonna call it side A, and the angle opposite of C, we're gonna call it side C. So actually, again, we have just these pairs that you have to view right away when naming those triangles. Okay, so that's the first thing you have to do. Okay, and then the last pair I will, my god, what I have done. I have to pair these. I have pair side and side. That's wrong. So I have, it's A with angle A with side A, and angle B with side EB. My god, this teacher. Okay, so after I've done this, the law of cosines, it's an extension of the Pythagoras theorem. So it's actually, let me see if I remember, it's A squared equals B squared plus C squared minus 2BC cosine of A. So when writing this formula, you have to see that here I have side A and here I have angle A. Okay, so that's what you have to be sure. So here's BC, here's BC. Okay, so we can write it using A, or we can write it using B. So that would be B squared equals A squared plus C squared minus 2AC cosine of B. And the last one would be, so B and B, right? The last one would be C squared equals A squared plus B squared minus 2AB cosine of C. Here we go, C and C. Okay. So if that's true, then let's try to solve the exercise number 1 when we have, and I'm gonna rewrite this exercise number 1 in here. We have B in here. We have C in here, and we have A in here. 16, 29, okay, and this is 112. So, and here they ask me BC, so we're trying to find A, right? So if we're trying to find A, just little baby, which one should we use if we're trying to find A? This one, or this one? I can't understand. You have to learn to talk first. Oh my god. So yeah, they're trying to teach little kids this crazy stuff, and then they come to school, they don't understand anything. So so let's go for it. So we have to find A. So you're gonna have A squared plus, we're gonna use the first one, B squared plus C squared minus 2BC cosine of A. Now we have, this would be C, which is 29, so this will be 29. Here we have B, right? This is B, which is 16. And BC, so you know what? I'm gonna write it here. A squared equals 16 squared plus 29 square minus 2 times 16 times 29 cosine of a, which is 112. Okay, now we have to do calculated work here. 16 square, so let's see, 16 square plus 29 square plus, no, minus 2 times 16 times 29 times cosine of 112. So that's 1444, right? Point something. Now this is squares, so I have, how do I solve this equation? Remember that the square root is the opposite of the square, so I have a equals square root of 1444. So that means that I have to actually take the square root of 1444.63, which is 38. So that's the side, 38. Does it make sense? Yeah, it does make sense. 29, 16, this 38. So A is 38. Sorry, 38. Okay, 38. So, well, that's an easy one where you have to find the side. So 1, 2, 3, 4, 5, and 6 are the same way, right? The problem here is when they ask you to find the angle. Okay, it's much more difficult. So looking these ones, you could have also used the law of sines to solve these triangles, and it still would work. So just see it as another option, right? The law of cosine is another option of doing the same thing we have done with law of sines. So the next video, I'll do it to solve an angle, which is a little bit more difficult, right? Okay, have a nice day. Bye-bye.